Looks like I'm going live. What do you think? I think I'm live anyway. I wanted to do this in landscape mode, but I'm on my phone. Don't know how to do it. But this will work. I want to use the mics on my earphones, but I don't know if this is working or not. So today we're going to be doing some machining. I'm sure most of you guys will catch this on the replay. I doubt anyone is going to be going live with me on a Friday night. Let's see here. I'm supposed to have a live page, right? Cool. Okay. All right. I think it's all working now. So I wanted to put out a video this week, but I didn't want to go through, there's a lot that goes into putting out a YouTube video. There's camera angle, focal points, focusing, and then all of the post editing. So we're just going to do it live. I've got 4 parts that I want to run tonight for my fly press. I said earlier this year that this is the year of the fly press for me. I'm really building out all of my tooling on this bad boy. And next, so right now I'm working on stuff for a customer named Jeff. I did a whole bunch of, I'll take you over here. I did some riveting tools for him. So he makes coffee spoons, okay? And so I made him a very, very delicate, it's about a 1/8 inch coffee rivet set. But there's a lot of clearance here because if he wants 2 rivets right next to each other, but on a traditional rivet set, the tools are quite thick, they're quite wide. And so when you can't do 2 rivets next to each other or else you're going to mess up one of the rivets when you do the second one. So I made him those along with this base. So this it's got a nice wide flange, so you can put a little toe clamp on there if you need to, depending on the fly press situation. And it's very stable. You can slide it around where you need it. And of course the bottom set indexes in there nicely. And of course my trademark recovery thread here, it's 3/8/16. So if anything ever gets stuck in here, you can use a bolt, like a 3/8 bolt, to drive that out. And I had to put in these 2 features. These are M8 threads. Those are for the retention knobs for my 0-point plates setup. So that's built in, Jeff. If you ever have a 0-point plate in the future, that's already built in there, backwards compatible. All right, so I need to get some stock. I'm working with 2-inch round stock. Hope I have enough. This is 4140 steel from McMaster Car. Hardens quite well. I usually go for about a 45-50 Rockwell. That seems to do pretty well. And so I need 3 lengths at 61 millimeters, and I need 1 length at 63. I don't know if I'm going to get it all out of this one. Oh, I've got some already cut right there. That'll work. So I've got a little over 300 millimeters here. So we're going to do some cutting. And if you can't hear me, if I walk away, I'm sorry. I'm hoping that the mic will pick up in these headphones. And you'll be able to hear me as I move around. Hi. And boy, I don't speak, where are you from? Is that Korean or Japanese? But yeah, thanks for tuning in, buddy. Okay. Looks like I've got one at 62 already cut. And then 75. I'm gonna get this mill going. And we'll do a little warm-up cycle while I cut some steel. Yeah, so tonight's probably going to take about 2 hours to do all this machining. So this is going to be a long live. You might not. You can leave anytime you want. Sorry, I'm plugging this phone in. There we go. You can leave anytime you want. Alright, so my Syil X7, it's a Siemens 808D controller. I've had this since 2020. Boy, the price of them have gone up a bit. I think when I bought this one, 20, 30K. I think 20 starting, 30 with some cool stuff. That was a lot back then, and now you're probably looking over 60K. I mean, I don't know. I'm not in the market for a mill. So rougher, tension mill, quarter-inch ball mill, 3/8 chamfer, and a 90-degree V-bit. And so right now what I'm doing is I'm going to run a warm-up cycle for 20 minutes. I got this program about 5 years ago from Peter Betts. I don't know his website, but he programmed this for Syil. I use the Siemens 808D controller and I love it. It works great. I'm gonna move you around the shop as I go. How's that? So, these two at 61. Three at 61. I got one there. Okay, this is my jet horizontal bandsaw. It's been with me a long time, doing really well. What I'll do, so I've set this stop up at 61 so I don't have to remeasure the rest of them. Waiting for coolant. Now I've got some coolant. Before cut. Oh, look. I don't know if you guys can see that. Just hit my step goal. 12,610 steps. So for you guys who watch this next week or whenever you see it, yeah, let me know. Let me know what you think. I've never even considered to go live, and then I called myself chicken tonight that I'd never do it, so now I'm doing it. Maybe I'll learn something from it. We got some nice parts anyway. let's go over to the 2x72 and deburr these parts a little bit. Sorry for the hand cam. So I don't know if going live is easier than doing a YouTube video or not. Oh, we got 2 pieces of stock there. Let's do one more. So, the project I'm doing today, you can see this, that's my pencil drawing. This is I mean, you could call the bottom part like a swage for blacksmithing, in the sense that, you know, the hardness tool here, 40-140, and then it'll have a concave shape for a coffee spoon. I've got 2 sizes. I've got the 15 mil, a milliliter, and 30 mil. So a small spoon and a big spoon. And so these are kind of like forming dies for the fly press. So the bottom die will have that big recess to form the spoon, and then the top die will be just the opposite, concave and convex. Well, you can press into that lower die to form I don't know. I'm sure someone's done this. I can show you what I've been using so far. Like that. So up until this point, I've made. So this is what the bottom will look like. It'll be round like that. Okay, that's the 15 mil size. About a big tablespoon. This is an old bearing out of a locomotive, out of a train, and then I just have a little ball that goes into there. I think this was an old bolt that I rounded the top to go in there. On a bigger setup, I for my bending die, I actually have a big, like 2.5 inch ball receiver for towing trucks, you know, for trailers. So this is ready-made. People buy these things for the fly press. There's already a flange. Turn this down so it'll fit in your, 1-inch bore. And you can use this for forming, making bowls. Probably would work for a large coffee spoon setup. But you know what? I've got the mill. I'm going to make it special, and then put it on my website for other guys who are similarly interested in, precision-made tools for their fly presses. Alright, got one more to deburr, and then we're going to start working on tooling. See over there? Sorry about that. I need a cameraman. You want to see what I see? This is my setup table. I've got my dead blow hammer, making sure my part is seated in the vise when needed. I've got some hex wrenches for soft jaws and for tightening my movable jaw in my vise. I use this to tighten the vise. It's got a very short handle, which flips out like that, so it could be a speed handle if I wanted to. What I like about the short handle is it keeps me from over tightening the vise. It's got an old coin die that says 0 fucks given. Make a lot of those. This one's worn out, and I just use it as a paperweight now. Got my 2 torque wrenches. One for torquing my self-centering vise from Silver CNC, and one for torquing the Silver CNC 0-point base plate. So I have one, set at each required torque value. I keep this handy in case I'm putting on or off soft jaws. It speeds up the process because this M-lock vise is quite long. It's got a big lead screw. And then I've got a 12-station tool set up here. I just 3D printed these inserts. Put them on some plywood that I had in the shop, in the wood shop next door. And so these are the tools that I'll be using. The 1/4 inch, I've got a 1/4 inch end mill. That's in the mill, we'll use that too. I've got a couple ups. I need to be able to clear 22 millimeters on a couple of tool paths. So I want to make sure that my 1/4 inch, my 3/8 inch rubber, and my 1/4 inch ball mill have enough clearance, have enough tool length. I normally, suck these tools down as far as I can for rigidity and surface finish. Like this right now is 27 millimeters. A stick out, so that'll be fine. So yeah, I'll go through and make sure they all work. 22 millimeter clear. Yeah. And then you can see here, when I drew this, I just wanted to know from this flange to the top of this ball, how much tool stick out do I need so I don't collide with anything. Okay. I need to replace this roughing end mill. Looks like it's worn out. Yeah, it started to chip in certain places, so I'll put a new one in here. Let's do that. This is my toolbox for my CNC stuff. Here are a few of my soft jaws, and when I say soft jaws, I make my soft jaws out of steel. These are permanent fixture jaws. For example, jaw is when I make my specialty fly press tool holder. When I do one of my ops, when I flip it, I've already machined some of the features, so I need that tool holder to register these features, and then a spot to get my zero in my programming. But I'm running 2-inch 4140 today. I'll need 2-inch soft jaws. Alright, 1 and 2. So we'll put these on the M-lock. When the mill's done warming up. That's it. This is by HTC Tool. The carbide turbo mill. 3/8 roughing end mill. There we go. And this thing is a beast. I love it. You know, it has a different tone. Sounds a little different than a helical end mill, but it cuts so well. Makes little chips that are kind of a pain to cut up or to clean up, but it works so much better than you know, a traditional end mill. And then I save my nice end mills for the finishing passes, which works really well. Okay, you see what I see. Let's see here. I'm just gonna stick you over here in the corner, and I'll be bending over. I'm sorry, but I'm gonna change out this tool. So here's the old one, pretty damaged from the last job. I've used this a lot though. Again, I'm just making sure that I've got enough stick out so I don't collide with this part. And this is fine. Now, I hope you guys can hear me. I apologize if you can't. It should be entertaining either way. Looks like the mill just finished. I don't know if it's going to come, you know, the mic's going to work out of my Pixel Buds, or if it's going to pick up on the phone. I didn't see a setting to change that. I'm not sure where you guys want to be when I do this work. Maybe right here. I'm learning how as I go. Sorry about the jostling of the camera. You try that? This is my 1/4" end mill. And this needs to come out a little bit. That's too close to the 22 millimeters for my liking. So let me change this real quick. Right. So the tools I'm using, got tool 3.1, that's 1/4" end mill. Tool 4.4 is 3/8" rougher. 5.1 is 1/2" end mill. 6.3 is 1/4" ball end mill. 7.1 is 3/8 chamfer, 4 flute. And 8.2 is a 90-degree rebit engraving end mill. So let's touch all those tools off. I don't know if you want to see this controller. Here, let's get you up here close. So for my process anyway, this is all the stuff that, I didn't know when I got into CNCing. I had zero knowledge. I was an army soldier, kind of with a dream when this all started in like 2019. And I didn't know any of this crap. And I got this mill. It was a leap of faith. And I didn't know what the heck I was doing. I didn't know how to change a tool, anything. Yeah, so anyway, so I've got my 1/4 inch end mill in there. And I think pretty much everything I'm running today is just in computer. So basically Fusion 360 is telling the machine, the diameter of the end mill, right? That's important when you're doing contour passes or high position passes, when you want to get within a very fine tolerance. So what I like to do on this mill, just so I have repeatability, and I have, every time I do it the same way every time. So my first step is I want to get centered over this stylus. It's a 12.7 millimeter stylus. So I come into when I got the Syil mill, I had all of these things preloaded. So I had programs, the tool setter programs, 4th axis. This was set up for 4th. I don't run a 4th. And then all of these different tests. I've got a spindle warm-up cycle by Peter Betts. That's all I have on here. Everything else is on this thumb drive or a network drive. So I'm just going to key down into tool change. And the reason I'm going over this again, when I started, I had no idea. I couldn't find a video that showed me this. So I've got all of these. Some of these are calibration, and some of them are actual measuring. So I'm going to go down to my diameter measure. I've got 3.2 or 3.1. That's the tool I'm using with 12.7 millimeter stylus. I hit execute. I hit cycle start, and then this does a tool calibration. But what it does, I hover it right over the stylus. It knows from when I've calibrated it where center is above that stylus, so it goes to that center point. Even though I don't need the diameter in this control, and in fact I'll probably clear that back to 0, but it sets me up to be center in the stylus in the same spot for every tool every time I do a tool cut job. I know that's a lot. Can you see in here? All right. That's just the way my mind is. I'm kind of analytical. All right, so I got the diameter in. Let's do the length. Little 3.1s, and it's 6 millimeters. On this program, you do put in the 6 millimeters or 6.35. You put the diameter of the tool you're measuring, right? The bigger the diameter, the slower it's going to rotate when it's doing its test, and the smaller the diameter, the faster. I mean, within reason. We're not talking huge changes in our case. Okay, so 3.1, 6 millimeter. Go. So now I'm doing, whoops. So now I've got the 1/4 inch end mill done. So now I'm going to go through all of these. Let me check that off that I've done the tool length, diameter, and length. Now I'm going to go through the rest. So enjoy the view of my backside. Next is tool 4. So I'm going to go into my 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 tool offset screen and delete the diameter that I tested. That'll be that. Tool 5. Alright, here's my 1/2 inch helical end mill. A little end mill tool holder, looks great. And then tool 6, this is the ball mill, 4-flute ball mill. To do the 3D feature, I'm using a toolpath called Scallop. I actually haven't used Scallop before. Lots of parallel, lots of contour, but Scallop should be interesting. So for the ball end mill, these other ones, I don't know if you could hear the motor, but for the 4-flute flat end mills, I tested the length as the tool was spinning. This is for ball end mills, engraving bits, drill bits, things like that. I just go straight down without it spinning. That makes sense. And if you're wondering why I look up like that, these safety glasses have readers. I know I look it, but I am old and my eyes don't work close up very well. Okay. 6-3. Now, tool 7-1. So this is my 3/8 4-flute chamfer. It's actually double-sided, so if you wear out one tip, flip it, put it in there. I buy it from Mari Tool, and I love it. I've got it really sticking out a lot farther than I normally would. But, you know, I've got this clearance, right? I just want to be able to clear features of the part and not collide with them and still deburr in the mill. My final part is a 90-degree V-bit. Okay. Single flute. I buy these from McMaster Carr. They last a long time. I buy them in 90 and in 60-degree angles. So the 60 degree is going to be sharper with an angle. a lot of engraving. Like, probably I average, I don't know, 2-3 hours a day, 5 days a week engraving right now. And I already touched that off earlier today because I was engraving, so I don't need to do that. I'm going to change the tool to 12. I keep my probe in tool 12. So I'll be touching off this stock with my hammer. So now we're going to do the soft jaws. So let's take this vise apart and put the soft jaws on. That's why I've got this bad boy. Before I take the back jaw completely off, I want to loosen the soft jaw. It's easier when it's still attached. Now, if you're wondering what kind of soft jaw this is mild steel, and it is very narrow. It's only about 75 millimeters or 3 inches wide, but I use it to engrave railroad spikes. Railroad spikes got a big bulbous head on one end, and this is the way to go. And then a railroad spike also tapers in. It's very parallel, but as it gets out to the head, it comes out a little bit, and since it's mild steel, this allows the soft jaw to deform and mold into the perfect shape to hold a railroad spike. And I've been using these for years, and it's definitely the way to go. Okay. Got these. So most of you guys are probably out at your favorite watering hole, having a pizza, getting beer. Well, I'm here doing Friday Night Live. But I tell you what, my age is catching up with me, and I'm drinking less and less and less. Don't get me wrong, I want to drink. Poison. I gotta grow up. What do they say? I want to eat my cake and have it too. All right. One more. we're about ready to start. Funny story about this hammer. I use this side for steel and this side for aluminum because I find that dirt and whatnot can be imparted into your part with a dirty hammer. So I try to keep this one clean, just in case I have to set an aluminum part. Flip it. And if you've watched some of my videos, you may have picked up that on this spindle, I've got two dogs that stick out. On this one that's on the left, I put a little prick punch in there, and I always turn it, and I always face my probes. I always put my probe into the spindle the same way every time to try and, get as much accuracy as I can. Now I do have an automatic probe, and I used to use this all the time. And I don't know, it just stopped working. It works in fits and starts. If I put new batteries in it, it'll work a day or two, and then it'll stop working. So I think I'm just gonna. I even sent it back to China. Syil had it sent back to China to have it repaired at one point, and it works. It worked for about a day. At least it worked then, but then it just stopped working. I think the batteries I use two 3.5 volt batteries. And as soon as they get to like they start at like 3.6 when you read them with the multimeter. As soon as they get to 3.4 or just drop a little bit, then the probe doesn't want to work. So, kind of a pain. We'll just use the Hymer. Alright. Everything on the big vise is G54. Everything on the little ER32 collet vise is G56. G54, G56. Since this is round, what I'll do is I'll let it touch, and then I'll use my Y to go back and forth until I have the strongest value, and then I'll touch there. The Siemens doesn't really have, it has a three-point probing cycle for round, but I like the 4-point approach, X, X, Y, Y, better. So that's what I'm doing here. Now I set up P1. Then I'll move over to the other side and get, say, P2 or position 2. Let me bring you in so you can see better. Okay. So now we're going to bring it around front, and we'll do position 3 for the Y value. So I'm going to touch it. And now I'll use my X traverse to make sure I get the strongest value. See how that changes? Right there. Right there. Now go in. Three. And now down the last. And then on the screen, so here's P4, and then I set my work offset. So I set my left X, right X, my front Y, and my back Y. I hit set work offset, and now I have a point exactly in the center of the part. Let's recover my probe. Okay. Actually, let's wash this window so you guys can see a little. It's dirty. When this coolant stuff dries, it's a mess. Is that even helping? Oh boy. It's not helping. Let me grab a paper towel. Do it one more time. It's a little bit better. All right, we're gonna make some chips. And then I got some other stuff that I want to do. Okay. So, let's get on this USB drive. Fly Press tool. Coffee spoon Swage, 15 mil, and Aqua. And since this is an untested program, I'm going to hit this feed override, go down to 0, and lock it in just for the first just for the first touch, just to make sure I didn't screw anything up, because I screw stuff up and then there's a big bang. Okay. Just double check my tools. 3144 63 and 75. All right, I'm ready. Turn this down, and I think you can see. Okay, I'm going to hit start again, and then just go up one. See how this goes. Lock it in. So I don't know if you can see, but it's hovering right over the part. So it's at the angle to where it's going to start, you know, milling out the center of this swage. So I'm going to hit stop. We go up to 100, full speed. Hit start again, and this is a loud end mill, but it works well. So let's see how this goes. Okay, walk with me here. Maybe we can get a better look. Oops. On the side. Not really. Sorry, guys. Yeah, that coolant is it's a mess. It's really hard to see. So we're milling out the center, and I'm taking an extra minute or two with this tool path to get my steps down to 0.5 millimeter. You know, generally they wouldn't be so thick. You could probably go the 10% of the diameter of the tool, but I want to prep it all one and done for the ball end that's going to go in here and scallop and smooth it all out. So I want to take out more material. I've got a flat operation going right now. It's taking off about a 1/4 millimeter off the top there. The 1/4 inch end mill will come in and clean it up again when this is done. Alright, tool change. Now we go to 1/4. Okay, everyone cross their fingers and hope that I got my tool length offset right and I just don't crash or break an end mill. Yeah. This is the 1/4 inch. So in Fusion 360 you have an option to duplicate a tool path. So in this case I duplicated the last tool path with a different tool using rest machining, and it's going to clean up everything that bigger tool couldn't get. So it shouldn't take too long for this to run. And I'm going to put option stop on. This M01. And then we'll take a peek here when this is, before this changes to the next tool. Because why not? And this end mill is not hogging that much. time. Friday Night Live. The wife, my wife, was over at her sister's house, probably drinking Miss Ultra. So I got the time. Okay, so now it's going to go, the 3/8 couldn't get down into the belly of this form, so now this 1/4 inch can get a little bit lower. There we go. Well, I hope this doesn't bother you guys, audio-wise, and it's already really loud, but I'm going to turn my air conditioner on. I have a rotary phase converter, and that thing heats my shop up. Oh. That's my last flat operation, just cleaning up the top surface. See here. Whoops. Sorry, you're staring at the ceiling. I'll be right back. Hold on. Sorry about that. I was replying to a comment. Let's take a look. Pull you off the tripod here. Let's see. Let's see what we got right now. You guys see what I see. That's nice. Okay, looks good. So the next step, we're going to go in there with a 1/4 inch end mill, and it'll do a kind of a spiral scalloping, what they call it, a scallop, a spiral tool path, down, 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 down to the bottom. And the bottom's still flat because the 1/4 inch couldn't go only so far. But you know what? I might have duplicated that for the adaptive to go in there again with the 1/4 inch ball mill and take out some of that, so it wouldn't. Yeah, I think I did. So it wouldn't be so abrupt when it hits that flat layer. So let's take off option stop and go to the next one. That's the 1/4. Let's see what it's going to do. Oh, it's going straight to scallop. Yeah. What an interesting, walk with me here. What an interesting tool path. It's gonna hang out here on this rim. Okay, can't see anything there. Sorry. I don't mean this to be like Blair Witch Project. It's gonna stay on top for a while, and because I've rounded that edge to be machine rounded. There we go. And it'll start to work its way down under the sidewall and clean everything up. I don't remember what my step over is. It's quite fine. It might be as fine, or step down, step over, whatever. It might be as fine as 0.1 millimeters. But you know, one and done. I want it to be smooth because any large imperfections in this bottom swedge or form tool, form die, will be imparted to the work you're working, right? So if I'm making a coffee spoon, I don't want there to be a lot of ridges in the copper. In the copper spoon, that would look stupid. Okay, so that's gonna take a while. So on to, let's clean up these. Get my hands dirty here, actually. Put some gloves on. And clean up these parts. I gotta ship them off tomorrow to Jeff. The parts I showed earlier, I'll show them again. Let me grab some rubber gloves, I'll be right back. Tell you what, I'm tired of washing my hands, so I'm gonna put these gloves on. I buy these from McMaster Club. And they're great. You know, I've had so many people comment on shorts or different videos I've done, or I'll be wearing gloves like this on my wire wheel or on my grinder. You shouldn't wear gloves on that machinery. Well, these will just tear. It's okay. This is just so I don't have to wash under my fingernails later tonight. Let me bring over what I'm going to work on. I've got 2 half-inch pullers for the fly press, one with a 1-inch Hardy, 1-inch shank. Those were hardened this week and then tempered. Then I put them in with 5% vinegar and an ultrasonic cleaner, and then washed them again in soap in the ultrasonic cleaner. Now they've been soaking in WD-40 and I'm going to wire wheel them. And then the same with these specialty coffee rivet setters with this extra clearance that I showed earlier in the video. And they have these very delicate neck down. They wouldn't do anything but copper with these, so that you can rivet as close as possible to the other rivet without deforming the rivet you've already molded. That makes sense? If anybody likes that, thank Jeff. So I love to spray these parts with WD-40 and then wire wheel them. I love using WD-40 as almost like a soap. It's a nice little soap lubricant, and it does a great job at cleaning the parts up, and then as far as I'm concerned, it's a ready to go finish. I'm getting better at this, but I've started to brand my parts. So that one says Power Forge, and 1/8-inch coffee rivet. Yeah, so that's all there is to it. So So the reason I put this in vinegar, and I buy the vinegar at Walmart. They use it for like weed maintenance in your yard. But I put it in a little plastic baggie, a thick plastic baggie. I put this in there and then put the vinegar in. I also use that on my corns. But what it does is it takes off that circuit, that port scale. It lifts it quite nicely. Sometimes a little is left on it, but the wire will go flat. Now I'm really excited to try these. That's that convex fuller, convex swage. I'll probably break these in tomorrow. I'm really curious to see what kind of effects I can do with it. So that scallop toolpath is starting to sound interesting. Let's go over there and see what it's doing. Oh, it'll change. Let's see. Okay, so we're doing the final deburring. We'll be able to take a look at this part. Oops. Oh wow, look how pretty that is. Oops, sorry about that. That's nice, guys. That is really nice. I like that scallop toolpath. Okay, so that's excuse me, that's the first part, or first op of the first part. So I'm going to flip it in this vise. The reason I did op 1 like this, I kept this part thick. Now I can flip it straight back into these soft jaws. I can do the hardy post. This is the bottom, so it'll have a 1-inch hardy square shank. A little engraving on it, and then that'll be one and done. So let me set up for that. I think that's all the phone battery I've got. I'll have to stop there. That, and I've probably given you all a headache with my yammering. Okay, I'm gonna put the charger on. Sorry, hold on. Okay. All right, so enjoy the view of my backside. I'm gonna flip the part, then we'll touch off. We'll do up 2. That is really great finish. You can even see there's a little spiral down there. Really heavy duty. So now we're going to machine this in. I've been asked in the past, do I always tighten that back jaw down? Do I always tighten it all the way enough? And the answer is yes. I tighten it all the way down. I don't over torque it. Just wrist torque, tight. But I don't want any lift on that jaw. If that jaw lifts up a little bit, especially on op 2, That's not precision machining anymore. Okay, so same as last time. I flipped the part. This is a new program that I've never run before. I don't want to crash my mill again. So I'm going to hit cycle start. I'm going to turn the feed rate knob down to 0, and then I'm going to walk that first tool in and make sure that everything's set up right. So I'm going to do that. Okay, hit stop, feed rate up to 100, pull this back on. I am so glad that I got that on live. I somehow crashed. I might have to go get my, I didn't crash. I'm gonna have to go get my laptop to see what happened. Let's get closer. What the heck did I just do? I thought it was ready. Huh. Okay, so there's one part scratched. Huh. I don't know what happened. Let's see here. That's one tough end mill. Yeah, so it went straight down and carved a nice big chunk out of that, which is cool. I've got material to waste there, so I'm gonna have to program. I'm gonna go grab my laptop. All right, I'm gonna have to program. Excuse me. I'm gonna have to pull up that toolpath. First, let's go up. Okay, no big deal. That's a tough half-inch end though. And all that's getting machined away anyway. So the G54 is still good. Since I'm using an end mill tool holder, I don't have to worry about touching off this tool again. I mean, it went through that metal like butter anyway. So, I'll be right back. I'm gonna grab my laptop. I take it with me, but I don't want to change my Wi-Fi because I might lose you. So, I'm gonna put a message of where I'm going, and then I'll be right back. Okay, I'm back. Got my laptop. Let's pull up Fusion 360 and see why I did that plunge move. What's odd though is this tool path should start with tool 4-4, which is my 3/8 rougher, unless I wanted to do a facing movement with my, I don't even remember. Let's see here. Where can you see? All right. Use my thumb drive. Can you see? Oops, wrong knob. my interwebs. Okay, you know why I crashed that? Because I had coffee out here, decaf, and I wasn't drinking it. All right. Have you guys checked out Fusion 360's dark mode? It's awesome. This is the new dark mode, and I have it, you can also change environments. So for example, I have it set on dark sky. When it was the old white mode, or light mode, whatever, burn your retina mode, I had it on River Rubicon, and it was pretty good. But yeah, thank you Fusion 360. God damn, that was so amazing. All right, let's pull up this part. Dust. Lots of dust. So here's op 1. Tool 4 is supposed to... Oh, we're not op 1, we're on op 2. Flip. Okay. So yeah, so that's a problem. Oh, you can't see because of the lights. Hold on. How's that? Better? So we're on setup 2. Make sure I have the right part. Op 2. Why do they make this window so small? Op 2 BH. Oh. Oh guys, I'm an idiot. Op 2 BH is the part. And I think I ran tooling. Whoops. I don't like this mouse pad on the Dell. Oh. I think I... Okay. Alright, well, whatever. You know, it's hard to... Okay, no excuses. I ran up to bottom hardy wear, which is the final toolpath, or the wear on the hardy itself, to make sure it's 1 inch, because I want to make sure that fits in my hardy plate. It needs to be, you know, within a couple thou at least. So it was going for the final contour pass. That is one tough end mill, because yeah, we hadn't milled any of that out. So I think if I just do the right toolpath up to BH, I need to work on my naming convention. We'll be fine. Let's try this again. Oh my goodness. Let's see. USB, black grass. Yeah, that's exactly what I did. Wow, rookie mistake. Let's do this again. I don't know if you guys like the light or not. I'm going to turn the light on so you can see. Okay. Let's try this again. I'm going to give you a front row seat. Okay. So, as a recap, I created an extra tool path because I thought I might have to do wear. And it was going in to do that final wear pass, and it just plunged and just beautifully milled that. I mean, you could have programmed that. That would have done that fine. It didn't sound bad at all. So now I'm going to make sure that I'm on op 2. Wow, why is that not capitalized? Op 2 BH, bottom hardy. And then you can see the difference in file size. The wear is only 2 kilobytes, and then the actual op is 476. Not a lot of code, but pretty amazing, right? Let's try this again. Same G54, but it should call up tool. It's just loading. It should call up tool 44 first. Yeah, 44, 51, 71, and then 82. Execute. Alright, so you can see what I see. Cycle start. This needs to change to 4. And for shits and giggles, I'm still going to walk this in. So watch this. I'm going to stop it. Stop. Turn off the coolant. Feed down to 0. My head hits stop. Now I'll hit start again. And we'll feed 1. And watch. See this? That's why I like the Siemens controller. I like this knob. I've used Syils in the past. I'm not a big fan of the way they do it with buttons, soft buttons. So we'll bring this down. I don't know if you can see or not. On coolant. And it should go to the side of it. And then stop. Yeah, so it stopped its Z movement. So now I've tested that we're good. Gosh. Think on your feet, Garen. Cool it back on. And then let her rip. With my finger on the stop button. And that sounds better. What it's going to sound like in that void. Skip. Oh, no. It's going down below it. That's why. This is that turbo mill. It is a game changer for me because my BT30 spindle, especially when I've got these fixture jaws in here, the parts up high, the tools down low, it can be you can get chatter, you can get extra vibration in the part of the tool, and it just doesn't cut well, but this cuts well. Now I'm flattening out the sides because this is a square hardy. So compared to my helical flattened mills, I think this is about 60 to 70% faster. I mean, I use it anytime I need to hog material, and I'm doing it conservatively. My tool path, whatever, feeds and speeds calculator tells me to take, to go harder, but I don't. Keep it easy. Oh, can't see anything. All right. Let's hit option stop, and then we'll take a look at this. It's done. Just hit that. Yeah. So I spent 20 years in the military, enlisted in 1998, retired in 2023. And they always drill into you attention to detail and slow is smooth, smooth is fast, right? But you know what? In a perfect world, right? But even Superman is useless when he's around kryptonite, and sometimes you will fuck up. Such is life. Ooh, that looks good. Can you see it? Oh yeah. And the finish isn't even that bad, but okay, so now we're going to go to that pesky half-inch end mill, which my machine doesn't really like. I think 12 millimeters, 12.7 half-inch is too much for my machine. Maybe better for a style that's got tighter ball screws. I don't know. But yeah, you can hear that sucker vibrating. Here, before you out. So my Y bearing will start complaining. So what are you doing? Yeah. So I used the 3/8 end mill to hog out as much as I could. You know, I might actually go back onto Marty Tool's website and look for a half-inch end mill rougher. So I can get a little extra, because I need the reach. That's why I go to these half-inch tools, is I need longer reach. Let's check this out. Can you see? Yeah. Kind of hard to make out. You're wondering where all that coolant's going. All the coolants and ships go to this tray, this catch, and it comes into this big reservoir. I've got this vacuum back here. Since I engrave so much, I've got some magnets set up in there to pick up the fine dust, and I'll vacuum them off. I don't really want if I can help it, I don't really want the magnet or the dust to get into the reservoir, if I can help it. And then this is my tramp oil contraption, which works quite well. You've seen it, it's caught some from last night's run. And so what I do now is I'll pop this, sometimes I'll use these, but I find it just as effective to pop this off. And I've got a box of these towels that pick up oil, and I'll just dip them on here and grab some of that oil, right? I like it. It's a good setup. Keeps my oil fresh. I run it every night. Gosh, that sounds, you can hear stuff vibrating. It's because I've got such a far reach. And I'm being really nice, by the way, with the tool path. I'm not working this tool hard. This tool and a different mill can do a lot more than mine, but I just don't have the torque or the rigidity to do it, especially in this setup. pro at doing these live videos and working scenes and stuff. Who else do I like? I like Aaron Engineering. That's his manual channel, but he's the one that I first discovered the Syil with. I think it's DCT, right? Design Creativity. The Design Creativity. What is it? I have a sticker. The Design Creativity, a technology channel. Aaron's awesome. He films out of Australia, which is such a cool accent. So what I'm looking at right now, oh, that's machining. Sorry about that. I'm looking at my stickers. I don't have very many, but got a few. I love coffee. I've got an even heat treatment oven. That's on there. I love Cool, the clothing brand. Haas. They're okay. Yeah, good stuff. Alright, so this half-inch end mill is about done. I think it's cleaning up the floor. Then it'll probably do a flat to a path, a contour to a path. And then we'll do some chamfering and some engraving. So should probably go over to the fly press here pretty soon and get mine. I've got this little Hardy adapter that I put in the 0-point press. Grab that, so, or I guess I could just measure it. How's that? I got a caliper. We'll do that. It's also nice to just be able to fit, to go regular gauge. Let's go with that. Okay. I've been doing bottle openers. This is my bottle opener down. Swage treasure. I was letting him fall onto the oak floor, and then started smelling like a campfire in here. We got a little tin bucket in there. So this is my my Hardy tool holder. I'm going to use this to test that Hardy that I'm milling and machining, make sure that it fits my setup. Okay, easy peasy lemon squeezy. That's all there is to it. This is 4140 with a 1-inch Hardy in there, and radius corners. And then these 0-point retention knobs fit in my. These retention knobs fit in my 0-point faceplate for the playplace, which I love. Let's see what we got going here. Okay, so we're taking off. We're doing a flat operation on the top. And I've got it set at 10% step over, which is 1.27 millimeters. I could definitely go a lot deeper than that. This is kind of an experiment, just to see what the surface finish looks like prior to engraving. Okay, almost done. Unless the surface finish of this toolpath is absolutely perfect, I'm going to increase the step over next time. And I do like the flat operation because it's going to dynamically, walk in. I like this style more than just a straight, surface op with the straight lines. I mean, I like them both. This one's fun. And if you do a 3D adaptive with nothing on the floor, it still leaves a little kind of a nipple, a little artifact in the center. So you have to do, oh, there we go, contour. So this is a contour with wear, and I've got the wear and the controller set to 0 right now, the diameter of the tool. And then that way, as we found out before, I've got a separate toolpath for wear I can run again if it's too big. Pretty nice. See, that fits. We won't have to run that wear toolpath. All right, we're going to break the edge and do a 0.5 millimeter chamfer with this 4-flute chamfer. Yeah, okay. Now we're going to do some engraving. Use my branding, my logo, my touch mark. You know what? I'm going to stop this. Oops, sorry about that. So my coolant is surging. That means I've got chips built up in the tray. So while this is running, I'm going to go clean that out and restore the flow to provide coolant for the bit. Oh, yeah, that works. Now you can't see anything. Okay, sorry about that. All right, so while that's finishing up the engraving, let's look digitally at these other parts. And so you can see what we're making here and how it's working. I'm going to turn the light out so you can see. Not exactly screen share, but hey. Okay. So let's take a look. I'm going to adjust this, bring you in a little bit closer. So I apologize for the manhandling. How's that? Is that good? Okay. Oh, I got a message. Daniel says, how many hours on your X7? Mine self-destructed at like 1300. Well, Daniel, I don't know. I've been using it since 2021. Mine has this Siemens spindle, and controller, and it so far so good. I'm not a job shop. I only machine for myself. For a time, I played with isometry, but that didn't work out. I wasn't a fan. But if we can Google how to look at the hours on a Siemens, I'll pull it up here after we finish this part and see how many hours I have on this. Probably not as many as you. I mean, I'm retired, guys. I do this for my own sanity and mental health. That's why I do this. Okay, so this is the part we're machining right now. And I've got every part set up. I created my own set of, I'll just show you. I'm sure you guys do the same thing. But I put the part in the vise when I do my cam, and that way when I'm doing the 3D operations, the 3D toolpath, it's aware of the fixturing and avoids them. So right now this is what I've got so far. I've got my main vise with different soft jaws set up automatically, and then I've got the silver CNC base plate and then the ER32 collet. So here was the part for Op 1. You saw that already. Here's the part for Op 2, what we're doing right now, which just finished. So let's take a look at that. Sorry, guys. How do I do this? Orbit. I'm so used to having a mouse. This is what we did just now. Fancy. And then when I get off live with you guys, I'm going to do this other part. So here's the top die. And then you'll see on the bottom, right, that will go right into the bottom form. Should look really cool. Okay, let's take a look at this part. Okay. Yeah, so I don't think I'm a fan of that step over I did with the 3/8 or the 1/2 inch, and I'm going to increase that next time. Let's pull this out. Okay. Alright guys. There it is. One and done. I get a lot less done when I'm on YouTube Live. I should have gotten all 4 of these done tonight. But I'll get them done tomorrow. So Op 1 was this 15 millimeter. Basically I modeled it, well, didn't even know, but the volume is 15 millimeters. I did the math beforehand, so I knew the diameter of the circle. Basically, I drew it out in a sketch, and then I did a revolve to get that shape. And then the 1-inch hardy with my branding. So let me catch up, make sure. Yeah, sorry to hear about your machine, Daniel. That sucks. I'll tell you what. When mine goes, I'll be saving a lot of money. It's like a charity project. I think I'd make more money not trying to run a business. But anyway, so thanks for everyone tuning in. Maybe a few of you will catch this on the replay, probably a lot more Friday night. And I hope to do this again, and maybe I'll get better. So please leave some comments. I doubt anyone will listen this far, but please leave some comments at how you think I could improve a YouTube Live, and I'll try it again. So, all right, on to the next part. Take care, guys. And I will say goodbye as soon as I figure out how to turn this thing off. Maybe the X. Goodbye.